Taylor, a birder from Melbourne, expressed concern about wind farms. She worried that they kill lots of birds, even though the numbers are low compared to other agencies.
Perhaps up to 976 million birds are killed each year in America, flying into windows. Hundreds of millions of birds are killed annually by feral and domestic cats. Up to 174 million are killed by power lines. 72 million are killed by pesticides, and perhaps another 60 million by cars. Communication towers conservatively account for another 4 or 5 million. It could be as high as 50 million. Why then, the argument goes, should anyone object to a mere additional 33,000 bird fatalities each year from wind farms? What arrogance to seriously propose such reasoning. Killing cute things is bound to raise the public ire. Think of baby seals in Canada. Killing endangered species is also politically unwise. Orange-bellied parrots are both cute and critically endangered. Modelling shows they will be extinct in the wild by 2015. Yes, I said 2015, just 2 years away. These birds breed in Tasmania in summer and spend the winter on the mainland. The Woolnorth Wind Farm at Bluff Point and Studland Bay on the rugged northwest coast of Tasmania is right on the orange-bellied parrot's migration route. The turbine operators report that no orange-bellied parrot has ever collided with a Woolnorth wind turbine. I believe them. There are so few parrots left, about 20 or 30 birds, they'd be extraordinarily unlucky to fly into a turbine. If an orange-bellied parrot is sighted within 50 metres of the wind farm, all the turbines must be shut down. I'm not sure how many birders there are out there in remote northwest Tasmania looking for rare parrots. It seems to me that if a parrot chose to fly near a turbine, it would be most unlikely to be A, spotted, and B, identified. The Woolnorth Wind Farm conducts vegetation surveys underneath its turbines to ensure that there are none of the orange-bellied parrot's preferred food sources present. If you're going to build a wind farm in the flight path of a critically endangered bird, there's probably not much more you could do to ensure its safety.
Sue Taylor. Well, those running wind farms insist they do lots of research and find numbers of birds affected are not what we might assume. Here's one of those doing work in Tasmania.
Hi, my name's Cindy Hull. I have a PhD in avian ecology and have been working in the field of avian research for over 20 years. I spent about 10 years researching penguins at a variety of locations. Some of my favourite memories are from the time spent in the middle of Adelie penguin colonies at Davis Station in Antarctica and amongst royal and rockhopper penguins on Macquarie Island. The noise, the smell, the chaos, I think it's life at its purest. While doing this work, I developed a simplistic notion that you can ascribe a personality to the different species of penguin. Rockhoppers to me are like crazy aliens, and for their size, they're incredibly feisty and audacious. Royals, on the other hand, are more gentle, inquisitive, charismatic. Emperors remind me of an elderly man shuffling through life, while king penguins are beautiful, but don't appear all that bright. All these descriptions are highly anthropomorphic and simplistic. They obviously don't reflect the complex ecology of these species, the adaptations they have to their respective environments, and the various natural and human-related pressures they have to deal with on a daily basis. So what drew me to work on penguins and other birds? I've always had a fascination with wildlife, and I want to do my part to assist in its protection. I also love scientific research, in particular testing of an idea, that is, a hypothesis, the challenge of designing a really good study, and perhaps most of all, the analysis of the data once it's collected. It's exciting when you analyse data and see patterns emerge, particularly if they're unexpected. It is particularly surprising when an expected effect is not supported by the evidence, which challenges our assumptions and paradigms. But that's science. It's designed to be objective. A good study aims to tease out real patterns from the noise and to make sure that results are not affected by our biases, expectations or other factors. We seek to identify the meaningful trends, the real effects, and let the data speak for itself. Scientific inquiry requires a sceptical eye, careful scrutiny and lots of critical thinking. Sometimes it's difficult to abandon a long-held theory or belief which the evidence doesn't support, but that's what the scientific process demands. So we just have to accept it and move on. I believe that the best way we can protect our wildlife is to conduct robust scientific research to understand the ecology of a species, the impacts it might be suffering, and to investigate if there's anything we can do to minimise the impacts. These days I work on flying birds, and no longer work in pure research, but in applied research. These days I apply that scientific process to the investigation of the effect of wind farms on birds and bats. I've been involved in this area of research for about 13 years at both Hydro Tasmania and Roaring Forties Renewable Energy. I work in this area due to my interest in birds, but also because I worry about a planet. I want to play my part, as small as it is, to reduce the catastrophic impacts of climate change and to protect species. The predicted loss of species, including birds, due to anthropogenic climate change is alarming. And what is worse is that the scientific literature is already documenting these impacts. I see generating electricity from renewables as one of the important tools to minimise further greenhouse gas emissions and avoid the worst climate change scenarios. My role's at a local scale. I provide input into the evaluation of sites for new wind projects, the assessment of potential impacts of a proposed project, and then the monitoring at operating sites. Each of these stages requires detailed investigations. Once a site is selected, we use the latest research to investigate potential impacts and provide input to the placement of the infrastructure, particularly turbines, with the aim of minimising impacts on birds and bats. After the wind farm commences operation, we begin monitoring to document any impacts. Properly designed, defensible monitoring strategies are key to understanding effects. We've been investigating the effect on birds and bats at the Bluff Point and Studland Bay wind farms in northwest Tasmania. We've conducted many studies, from monitoring required as part of our state and Commonwealth permits, to targeted studies that we've initiated to try and understand a specific issue, or where possible, to reduce an impact that's been documented. Given that knowledge cannot evolve without it being communicated, we strive to make the results of all our studies publicly available. We also take as many opportunities as possible, like this one, to disseminate our findings to the general public, governments and others. I've provided links on the ABC website to our publicly available reports and our papers that are published in the peer-reviewed scientific literature. We've learnt a lot in the last 10 years at these wind farms. Some of the key things we've learnt are, firstly, not all species of bird are at equal risk of collision with turbines. We found that only about 20% of the species present at these wind farms are involved in collisions with turbines. The vast majority of collisions involve birds colliding with moving turbine blades, and those at risk are the ones that spend time in the region the blades move, which is called the rotor-swept area. Modern turbines have a rotor-swept area of between 65 and 115 metres, meaning the blades sweep through the zone from about 35 to 125 metres above the ground. So any birds that don't fly in this zone are very unlikely to collide, such as those that are present in trees or shrubs. Secondly, bird collisions with turbines are statistically rare events. What we need to know is if the number of collisions that do occur could be having a negative impact on the conservation status of a species. That is, will it be pushed closer to extinction? Thirdly, similar to birds, there are specific features that make some bat species more at risk of collision. The primary factor again is whether the bat is present in the rotor-swept area of turbines. Fourthly, we've done a lot of work studying how eagles respond to the presence of turbines. A 3-year observational study we conducted at these wind farms found that eagles adjust their movements through the wind farm once turbines are installed. They also alter their behaviour in response to whether the turbines were active or not, and under different weather conditions. The key finding was that eagles demonstrated an awareness of the turbines and usually actively avoided them. One of our key areas of current research is determining what are the factors involved in collision risk. Only by understanding these factors can we hope to develop strategies to reduce the risk. There is a lot of research into the effect of wind turbines on birds and bats around the world. Until relatively recently, much of this research wasn't published in the peer-reviewed literature. That's not to say that the research hasn't been thorough and appropriate. It just means that it hasn't passed a formal peer review process, which provides a layer of credibility. Also, sometimes this material is difficult to access, unlike that in scientific journals. Part of my job is to keep abreast of all this research. It can be daunting, as there is a lot being done around the world. There are now some excellent scientific conferences held each year on the topic of birds and bats and wind farms, and this sharing of knowledge and findings is critical to the scientific process. These conferences involve lots of intensive discussions, problem-solving, debates and disagreements. That's what happens when you put a bunch of researchers in a room, but it's this that allows the evolution of ideas and communication of knowledge. It's interesting that while some of the issues found at wind farms are the same around the world, some are not. It's important to remember that assuming what someone found at one site will automatically be found at another doesn't constitute good science. Assumptions need to be tested or strategies trialled. While a lot's been learnt about wind farm effects, there is more to be learnt. Unfortunately, in the area of wind farms, there's a lot of misinformation and myths, even when scientific evidence exists. Inaccurate information or myths do not progress understanding, or in fact save species. In my view, it only muddies the water, distracts focus, and wastes time. One of the myths that I regularly encounter is that it is predominantly raptors that are at risk of collision with turbines. Yes, there are some wind farms that have demonstrated impacts to raptors, but there are a number that don't. Further, what we found at our sites is that not all raptors are equally affected. Raptors are one of the groups of birds that are often the focus of community, but that might be more about human perceptions and emotions than what the evidence shows. We need to be careful that focusing on one group doesn't result in us being blinded to impacts on others. Instead, we need to objectively view the results of robust scientific studies to see if species or populations are being significantly impacted. Wind farms are one of the few sources of impacts to birds and bats that are being systematically monitored. Most other forms of energy generation do not monitor impacts. Nor do we have widespread systematic monitoring of all the other human-related activities that we inflict on species, such as collisions with cars, power lines, windows, poisoning, shooting, pollution, etc. No data does not mean no impacts. It means no data. Although it varies across jurisdictions, state and Commonwealth regulators often require that the wind industry intensely monitor its impacts. We support and endorse these monitoring and reporting requirements, but it has led to the incorrect perception that this is the only industry that has impacts. I think it's our duty to determine the range of impacts on birds from all sources, determine which are the most significant and try to reduce them. Finally, it is important that the facts, derived from robust scientific studies, are communicated and that we're not simply perpetuating myths and misinformation. It's the least we can do.
Dr. Cindy Hull works for Hydro Tasmania and studies the way birds and wind farms interact there. She lists their results so far on a link you can find on our Occam's Razor website. Next week, Ludwig Leichhardt.
Okay, and as you can see, up here we study the links and the interactions between grey kangaroos and low-level wind turbine turbulence test rigs. Wobbles on a lot to YouTube. Ciao. P.S. There's never been a kangaroo harmed by this wind turbine, nor a wallaby, nor a chough, nor a currawong, nor a bowerbird. It's a pretty harmless windmill.